Hello friends, welcome to SR Academy.
Welcome to SR Academy. Empowering minds, igniting curiosity. Your gateway to knowledge unleashed. Let's get started.
To discuss about engineered wound healing. So engineered wound healing is something we are just giving the brief introduction how exactly the wound healing requires how exactly the engineering kind of concept is happening in the wound healing, and also the later part, half of the other of this particular topic, will be discussing about what are the differences between the adult and the fetal and adult wound healing process and all, right? So tissue engineering strategies are being employed to enhance the wound healing processes. So what are the different concepts or the different various concepts of or various principles that is employed in tissue engineering, okay, or different strategies which has been employed to enhance the wound healing processes that we can discuss here. For example, the scientists, there are many strategies of tissue engineering that have been used to enhance the wound healing processes. For example, scientists have used a porous template, a porous template in the sense a template which has got more number of pores. Alright, so pores. So this porous template is made up of a collagen 1 and chondroitin 6 for sulfate. So for what purpose they will use? This is to mimic the extracellular matrix, okay, so of the dermis of skin. That means we know that every cell and every tissue has got extracellular matrix. I mean, every cell has tissue has got extracellular matrix. So dermis of skin, that is means the dermis layer of the skin. So whatever the ECM is there, no. So in order to mimic that function, so the scientists have developed the template, okay, which is made up of collagen 1 and chondroitin 6 sulfate, okay, which was successfully used for the mimicking the extracellular matrix of the dermis of skin. That means this particular whatever the porous template that used, that acted as extracellular matrix or scaffold, what we discussed in the previous module or previous chapter. Whereas this template was fabricated with a range of pore size and degradation rate. So here this particular template is actually fabricated. Okay, that means that's the porous template. No, what they made, scientists made, that is fabricated. Fabricated in the sense they have manufactured it, right? So with a range of pore size and degradation rates. That means the pore size will be depending on what are the nutrients should be passed through that, what are the cells, so based on the cell migration, that there are many factors will be there. For all those factors should be considered, and you should arrive at conclusion that that pore size should be in this particular range, maybe in microns or maybe in less than the microns, like that. So and also the degradation rate, because this particular porous template, when you use it as a ECM, it should not stay there for a lifetime. It should do their function only for till the wound heals, and when the wound heals, this particular collagen 3 should degrade, collagen 1 or this chondroitin 6 sulfate which is made of which is used to make this particular porous template, that has to degrade after its function. So both they fabricated for the various range of the pore size and degradation rates. That means we are having, for example, I am having one particular fabricated porous template which has got the size of 100 to 200 micron pores, and degradation rate is for example degradation rate, it may be a little bit, it depends. So for example, if the first topic was what I just told you, the first example 100 to 200 micrometer, so for that degradation rate can be a little bit slower. Okay, imagine it may be after 2 months it will degrade. Okay, now the second one I will second porous template I will produce, and this template will have the particular pores with size of around consider size of around 150 to 300 or something like microns, right? So now the degradation rate will be changed. Okay, that may be the lesser than the earlier what I mentioned, or it may be more, it depending on the experimental and other factors which are involved in the wound healing. Definitely, I just wanted to tell you that how exactly the range of the pore size and degradation rate are measured, and based on that the fabrication will be done, and we can have a number of fabricated the porous templates which can be made by using collagen 1 and chondroitin 6 sulfate. Now the time required for 50% reduction in the wound area was measured. So how exactly it can be done? So what is the time which is required for the 50% reduction of the wound? That means, that is very simple English, I hope you understood. So whatever the wound is there, now imagine this is so much big wound is there. To reduce the 50%, how much time it may require, that has to be measured. Now the pore size in the range of 20 to 120 micrometer was found to be optimum for improving the wound healing due to the migration of the fibroblasts. As I told you here, with the different range of the pore size and degradation rate they have used, and here they came to know that around 20 to 120 micrometer, that is the range, that is the optimum range. Optimum range is nothing but what this will get after optimization. What is optimization? By trying a trial and error method for many times, many experiments should be conducted with different pore size, and the result should be seen, and if the result, wherever the result is better, that will be our optimum parameter. Now here the optimum parameter, that is pore size, it ranges from 20 to 120 micrometer. Okay, so that was found, that this particular range was found to be optimum for improving the wound healing due to migration of the fibroblasts. So that the migration of the fibroblasts has to happen for the wound healing. For that you need to have the the pore size should be either it should start from 20 to 120 micrometer. So usually wound contraction occurs after the migration of fibroblasts. Now imagine, now you have a layer, you have this particular layer or the porous template. Now the fibroblast migration is done. Okay, so now after this particular migration of the fibroblasts, the wound contraction which takes place, okay, in the provisional matrix. That's what we discussed in the previous topic. If we just go back and see the provisional matrix, it will happen in the provisional matrix. So subsequent conversion into the myofibroblast. Now fibroblast will be converted into the myofibroblast. Before the movement of the fibroblast through this particular pores, it will be just a fibroblast, and then when the contraction happens in the provisional matrix, and subsequently that will be, this fibroblast will be converted into the myofibroblasts. Now hence, when the fibroblast migration is delayed, if fibroblast migration through these pores is delayed, so automatically wound contractions and scar formation is also delayed, thus allowing the sufficient time for the wound healing process. So we need to make sure that the fibroblast migration should be slower. Why? Because if the more time is there for wound healing, the better will be the wound healing process, or the scar formation will be lesser. Understanding? So wound contraction and scar formation, automatically the wound contraction and scar formation is also delayed, thus allowing the sufficient time for the wound healing process. Now the pore size and the degradation rate, these two things plays a very important role. From the beginning only I am telling, right? So the pore size and the degradation plays an important role in the determining the cell adhesion and as well as infiltration in the scaffold. Obviously, how exactly this ECM, we are having the ECM like structure, right? This is the porous template. So how exactly cells are going to adhere to it, or adhesion, that means how they are going to attach. And then infiltration in the scaffold. That means the scaffold is nothing but, here is this whatever the material you are using, that is a porous template which will mimic the ECM. So whatever mimics ECM is a scaffold. Now the cell has to go and bind or attach to it and then infiltrate. That means which should involve inside this particular scaffold, and where the cell migration takes place. So at very small pore sizes, what happens? Fibroblasts cannot infiltrate. That means it cannot pass through this particular scaffold. If it doesn't reach the if the fibroblast doesn't reach the scaffold where the cells are dividing, then the cells will not get the structural support from the fibroblasts, or myofibroblasts will not be there because of the absence of the myofibroblasts. The wound healing process will not be complete. So moreover, the degradation time should be fine-tuned. That means we need to make sure that the degradation has to be altered or manipulated. That means whatever we want, that has to be tuned so that the degradation time matches with wound healing time. So if imagine the scaffold which we have with the scientists have developed, if that is degrading before the wound healing, then what happens? Then there is no effectiveness. There is no wound, that whatever the wound healing is there, that will not occur. That's why the degradation time has to be fine-tuned. Make sure that the wound healing time should match with the degradation time. As I told you in the beginning itself, the degradation why we require? Because after its function, it should not stay there. It doesn't mean that before its function also it should not stay there. Understanding? So until the function is being completely done by the scaffold, that particular porous template, or what we call as a scaffold, which is mimicking the ECM, has to be there, and it should be doing its function. The cells will come and attach, and the cells will differentiate, they will undergo division, and then they will migrate and then proliferate, and finally the tissue should be formed, and then the fibroblast, and then this particular porous template should be degraded. Understanding? Now the normal wound healing rate of the skin is 3 weeks, and for peripheral nervous it's 6 weeks. This is the normal duration. That means the range of the duration we know. That means even this degradation rate of the ECM or the scaffold or the porous template what the scientists have developed, that should match to this. If you are talking about the normal wound healing process of the skin, then the degradation should be tested for 3 weeks. So that is one thing. And for peripheral nervous nervous system, or if you are talking about then for peripheral nerves, then it should be 6 weeks. So another alternative for the polymeric scaffold are the cell contracted extracellular matrix gels. That was the porous template base. So far we discussed, and the different engineering aspects which can be involved in order to have a proper and effective wound healing we discussed. And another alternative for the polymeric scaffold or this porous scaffold are the cell contracted ECM, that is extracellular matrix gels. Okay, so this gels usually made by this particular, again comes under the class of polymers. So it exploits the cell based contraction for the formation of the tissue like constructs. That means it uses the mechanism of cell contraction to form the tissue constructs. So it is found that the increase in cell number and the contraction rate contraction increases, and with a increase in extracellular matrix contraction, the contraction decreases. So what happens here? When there is the cell numbers are more, the contraction increases definitely, because more number of cells are active. And with the increase in extracellular matrix contraction, what happens? The contraction decreases. That means more are the cells, more will be construction. Lesser the extracellular matrix, higher the extracellular matrix contraction, what happens? The contraction of cell or tissue decreases. So that these are some of the factors which are affecting, which are related to each other. So this cell contracted cellular matrix gels form a dermal equivalent. That means with the help of this contraction mechanism, the cellular contracted cellular matrix gels form a dermal equivalent, okay, and are commercialized for tissue engineered skin products. For dermal equivalents it can be used. So that was about the engineered wound healing. Under this third topic we are having the fetal versus adult wound healing. So fetal wound healing that occurs very rapidly without scar formation, while adult wound healing is very slow process with the formation of fibrosis and scar at the injured site. Definitely in adult wound healing we can see the lot of scar formation, whereas in fetal wound healing we cannot see because this happens very rapidly, whereas adult wound healing takes a long time because the wound is little bit bigger, or it requires a lot of reconstruction of the tissues, whereas in adult wound healing the reconstruction is little bit slow, whereas in fetal wound healing the reconstruction will be faster. So moreover in adult wound healing there is a poor reconstruction of epidermal and dermal tissue at the healed wound site. There is no much proper reconstruction of the dermal and epidermal layers. So however the process of reepithelialization and connective tissue contraction is almost same in adults and embryo, but mechanisms what they follow they are different. So in embryo, what happens? The gap in the epidermis is closed. The completely whatever the gap will be there, in the epidermis layer, that will be closed by the contraction of the actin. Okay, actin pursuit string. Okay, but in case of the adult, what happens? Epidermal cells migrate and fill the gap. So there is a difference. See, there it will be because of the contraction of the actin, that will be filled. Where here it will be the myosis is closed by the contraction of the actin pursuit string. But in the case of adult, the epidermis cells migrate and fill the gap. So that's the major difference. So myofibroblasts in the adult wound helps in contraction of the exposed connective tissue, thereby bring the two edges of the wound closer. So imagine the wound is formed, the other two edges of the wound will be brought closer by the myofibroblasts in the adult wound. In adult wound healed. Okay. So on other hand, the fetal wound healing, what happens? The embryonic cells help in contraction of the connective tissue. Because of the contraction of the connective tissue, the wound which will start shrinking like this. Okay. So another major difference in that is that the adult wound healing, there is an extensive inflammatory response, while in embryo there is no inflammatory response. That obviously, so in embryo the inflammatory response will be less, whereas in adult wound healing, what happens? The inflammatory response will be more. Okay, it will be very extensive. So fetal wound contains a basket weave, that means basket weave, collagen matrix and collagen 3 as the major components of this ECM, while the adult wound contains bundles of collagen, okay, and fibronectins as the major ECM component. That's the difference. So for fetal we are having basket weave, that is nothing but we are having collagen matrix, collagen 3, whereas in adult we are having the bundles of collagen and fibronectin. So fetal wound exhibits a low tension, while adult wound exhibits a higher tension. You can also see this particular topic as a subtopic as for 5 marks, that is fetal versus and adult wound healing. That is also can be an expected question. Okay, so since there is no inflammatory response and minimal scar formation in fetal wound healing, it would be interesting to understand the mechanism so that they can mimic them in the tissue engineered medical products, that is STEMs, for effective wound healing. So since we know that when compared to the adult wound healing, the fetal wound healing gives zero scar formation. So this makes them a very effective, the model for studying in depth, so that we can understand how exactly the things are happening, and we can mimic in those particular mechanisms in the tissue engineered medical products for effective wound healing without scar formation. So that's it. Next topic we are having angiogenesis, that we will discuss in the next class.